Hi, everyone. My name is John Hayes, the producer for this session. I'd like to introduce everyone to Alex Gilmore and Jesús Barrasa, who will be leading the session Ontology Creation with the Neo4j Data Modeling MCP server. Jesús and Alex, floor is yours. Take it away.
All right. Thank you. My name's Alex, and I'm on the AI field team with Jesús. And so today we're going to be talking about using the Data Modeling MCP server to create an ontology that you can use with your data.
Excellent. Yeah, and I'm Jesús Barrasa. I'm the field CTO with Neo4j. And I've been working quite a bit with Alex recently with our AI customers. And today, we're really excited to give you this tour of the MCP server with a great example. And I wanted to spend a minute. Why did we decide to mention ontologies? And that's a term that many of you might be familiar with, and that's becoming somehow popular in tech spaces. But while the MCP server, we refer to it typically as a graph modeling server. It's important to understand that an ontology at the core is not very far from a graph model, right? An ontology, if we think of it formally, it's like it's a formal description of a domain, right? And that's exactly what a graph model describes. And actually, we're going to end our experiment formalizing the model that we're going to be creating with the MCP server in one of the standard languages and formalisms to express ontologies. So hold that thought there, but I wanted to kind of connect these two things. So an ontology can have more elements, but at the core is a collection of an enumeration of the entities and the relationships in a domain, which is exactly what a graph model captures. So we'll get to that in a moment. So let's get started. So like Alex was saying, we're going to be using the MCP server, and this MCP server is relatively recent, but has been around for a few months. And we thought we'd share with you some pointers here. So you have a blog post by Alex himself when he announced the availability of the server. So feel free to go have a look at those, because that will give you additional context. There's even a YouTube video that Jason you did, like a basic introduction on how to install it and how to run an iteration on, I can't remember what sort of data was he using, but it's another interesting asset. And the final one, I believe it's the actual documentation, right? This is an open source component that you can get on GitHub, and I think Alex has done a great job at documenting it. So these are three relevant pointers that we thought we'd share with you. And with that, the plan today is to take you through a worked example step by step, and we picked two pretty cool data sets, we think. So the first one is the blue plaques data. So the blue plaques are these. I'm based here in London, and this is something that originates here, right? So it's been running for over 150 years, I believe, but it's kind of these commemorative markers that are in buildings. You can see some screen captures there, and it's a public data set. And basically, what these markers are, they just honor the, popular, notable, let's say, men and women that lived at these buildings because they lived, they worked, and there's some interesting ones. I've put the image of the building where Jimi Hendrix used to live, but there's musicians, there's all sorts of writers, politicians, I think Karl Marx is another one, Alfred Hitchcock. So there's plenty of celebrities that it's actually a very interesting kind of walking tour of London. I'm spending too much time, but this is one data set that we're going to use. We're going to be using it. It's important in its original form as web pages, HTML. There's versions of it that are structured, but in this example, we're going to use it, and Alex will go in more detail about that. So that's the first one, but we're going to enrich that with public transport data. So we thought it would be an opportunity to connect two separate data sets, but also to show kind of the process in that you go through when you run multiple iterations of a model, right? So you start with a basic version based on some data, but you extend it and enrich it over time. And this second one is it's more structured, and it's basically the tube network here in London that, as we're going to see, happens to connect nicely the locations of the plaques. So I think with that, I'm going to hand it over to you, Alex. Sorry, I took a bit too much, but
that's all good. Yeah, so as Jesus said, so we have some data sources that we're going to take a look at. And before we jumped into the demo, I did just want to kind of cover the general workflow that we typically see with this MCP server. So first, we have this data discovery phase. And so here we're going to provide sample data. So that's going to be those web pages for the blue plaques, and then the CSV files that contain the London Tube information. And then we also need to provide some use cases that we want our graph data model, or ontology in this case, to address. And then once we provide that, the agent is going to also be able to use the data modeling MCP server to find example data models. So the server contains a collection of example data models that it can pull into the context window and use to inform the model generation. And so once this data discovery phase takes place by the agent, then it will attempt to create its first draft of the data model. And so this will basically involve the agent creating a JSON object representing the model structure that is taken by the MCP server, and it will pass it to a validation function on the server. And so what happens here is that the function will take that JSON object and it will try to map it into a pydantic model that exists within the server itself. And during that mapping process, if any errors occur, then they're captured and returned back to the agent so that it can fix any mistakes in the model. And so and as an example, we're looking for things like, duplicate properties or duplicate nodes. We want to make sure that if a relationship is defined, that we have the source and target nodes also existing in the data model. So it does validation checks like that. And then once we have a valid data model, we can use the visualization tool provided by the server to create a Mermaid configuration. And Mermaid is the visualization engine that a lot of AI applications support. And so we'll create that configuration, and then the client application can then visualize the model according to that configuration. And so then once we have the model visualized, it's easy to provide feedback as the user. And so we can suggest modifications to the model that we'd like to see. And then we'll go back into this validation and correction stage where the agent will make modifications, validate the model, visualize it again to us, and then we can repeat this process as much as we'd like. Once we have a model that we're happy with, we can export this model, as a JSON object, or we'll take a look at how we can export it as an ontology in the demo. Or we can also generate Cypher code as well. So the MCP server supports generating the ingest cipher according to the data model. And just real quick, to set this up, it's fairly simple. There's no database connection required to use this MCP server, so you can just add it to your MCP config file with just a simple command here. All right, and so with that, we're going to go into the demo part, and then real quick, just so that everyone knows what we're going to be covering here. So first, we're going to create a data model of the blue plaques data. We're then going to add the London Tube data. So we'll have our first data model, and then we'll augment that with the additional London Tube data. And then once we're happy with that, we're going to convert that into a ontology format. All right. So we're going to be using Claude Desktop to do this. And so we already have the MCP server connected here. And so if we look at this plus button, we can click on that and then go to add from data modeling. And data modeling here is just what I've called the MCP server. And then we can see a list of all these resources here. And really what we want is this create new data model prompt. And so this is going to give us a parameterized prompt where we can provide some information about our data. We can provide use cases that we'd like the model to address, and then maybe any desired nodes or relationships that we already have in mind for our model. And we'll package this up into a pre-written prompt that also contains instructions to the agent on how to effectively use the data modeling MCP server. So for this data context, I'm just going to copy some information I have about the BluePlex data. And then we want the use cases. We just have a very simple use case at this point. We basically just want to store this information in the graph right now. And then we'll add the prompt. And so if I click on this now, we can see this is a text file that gets attached, but we can see we have our use cases, and we have the data context, and we have all of the additional instructions on how to use the server that's going to be provided to the agent. And so we also need to provide some example data. So we're going to give just a few links to some of these BluePlex pages that Claude can analyze. So with that, we're just going to send that off. All right. So here it is retrieving the web page information. And here it's checking for relevant example data models that exist on the server. So it's going to list those out. And so we can kind of see here in the response, we have a patient journey model, we have a supply chain model, among many others. It doesn't find any that exactly fit our data, so it chooses not to pull any into the context window. And now it is generating the first draft of the data model. And so it's calling this get mermaid config. And that's going to both validate the data model that's provided and then also generate that configuration that we just saw. And so here we have our first pass at the data model. So we have the plaques. We can see that we're keeping track of the location that they're at, the subject, the profession of that subject, and the category of the plaque. And this looks right. Does this look good to you, Jesus? Anything that we should change here?
Good. Yeah, no, I like it. And I wanted to comment that, obviously this agent actually implements very much the approach that we would follow in the field, right? So when we are doing actual graph data modeling, I mean, we look at the data sources, we ask, try to get the kind of questions that the model will have to ask. And basically that's the essence of the operations, because that all these kind of best practices are probably captured in the prompt, and I guess can be adjusted. But that's the interesting bit, that it's a great assistant to basically accelerate and make each iteration, instead of being probably a few hours, it can be just a few minutes. That's the amazing here. No, that looks. I think the model looks great. I mean, it's a bit
Awesome.
small, I have to say. I don't know if people are going to be able to read in detail, but I think, yeah. Oh, that's great. Yeah, perfect.
Okay. Yeah, hopefully that's big enough for people to see on their screens. Cool. So now that we have the BluePlex data that we're happy with, then I think we can add the London Tube data. And so we could have done this all at once in just one, initial prompt. But I think what we wanted to demonstrate here is that we can have a pre-existing data model, in this case, the BluePlex data, and then we can take that and then we can add additional data to it. So we can augment existing models with this server as well. So here, we're just going to copy this information about the London Tube that I have. And so we're not going to be using any pre-written prompt. We're just going to say, please augment this data model with this London tube data. And then the use case that we have is what we would like to do is find the shortest path between two different blue plaques locations via the London tube. And so we're going to pass these two CSV files that contain the London tube information that we'd like to ingest. So we'll send that off.
And that nicely captures the fact that, because this is more structured data, right? So these are CSVs that contain data that's well defined and probably cleaner than what we had in the previous example. So that's one of the questions while this is running, or maybe we can save it for later. But people are asking on the chat. I mean, what we're doing here is just the modeling step. I mean, we're not yet bringing data into the graph. I mean, we're just creating the model, and I think so. There's questions, and we can elaborate on that later. Like, where does that take me? I mean, do I generate Pydantic out of these? Do I create an ETL pipeline? So it's all of those, but this exercise and this server is helping us with the modeling step exclusively. So
yeah, and this, I mentioned that we have those additional tools in the server that can generate Cypher ingestion code. And so for the actual ingest process, you can use this server to create an ingestion script, or that you can use to actually load your data.
But I think it's good practice, and I think it's great that we're focusing on the modeling, because it's definitely worth persisting, formalizing, documenting the model, even versioning it as it changes over time. And kind of separate that phase from the actual ingestion, which is more the implementation detail, how data moves, or how we use the model to drive ingestion in one or the other form. So, but yeah, that's great.
Yeah.
We have the new version of the model now.
Yep. And so we can see here we have the original model, which was plaques, categories, locations, subjects, and professions. And then now we have, stations, which are now also attached to location. And then we can see which tube line that station belongs to. And we have this relationship that exists connecting the stations together. All right. So I think this looks good to me, unless, do you think there's anything that we should change about this?
I mean, I'm good. It looks like probably this. I mean, the thing that I would question, and maybe it's too much of a detail. Should the tube line be a separate node? Could it be maybe a property of stations? But that's, I don't think is a critical one, and we didn't specify any question in that direction that would justify one or the other. So I would not over-engineer it and leave it as is, and then. Well, as we're going to see, as we're seeing, this is an iterative process. So if additional kind of use cases, new questions, or new type of workloads justify the change, we could make that evolve.
Yeah, no, that's a good point. I don't think it's really relevant to our use case. So we could probably remove this node if we wanted. Yeah, cool. Well, I think, for this demo, I think we're good to go. So now I'm just going to say, can you export this as an OWL ontology?
Yeah, and maybe I can say just a couple of words. I mean, OWL is for those of you who might not be familiar with it, is a formalism, is basically a standard vocabulary to formalize ontologies. That's a standard by the W3C, and basically in an ontology, in an OWL ontology, what you have, it uses kind of slightly different terminology. What we call node types in OWL is referred to as a class. What we call relationships in the OWL world are called object properties. What we call the attributes in nodes are data type properties. So it's kind of, but the structure is the same. I mean, OWL describes the world as a graph, as a collection of classes with relationships that connect them and properties that describes them, and it has a number of serialization formats. And this one that we're using at the moment is called Turtle. As Turtle, it's meant to be one of the kind of more human readable, but there's multiple other serializations that you might have heard of. So and again, the translation, as Alex is showing here, is pretty straightforward. So basically, node types become classes, and properties become data type properties in OWL, and relationships become object properties. And one of the interesting things about this formalism is that it's a kind of a standard, right? And a standard in the sense that, it's a W3C1, and there's a number of applications, and we picked one here, Grapho. But any application that understands that can parse RDF or OWL will work, and we've used. I personally use sometimes Web4j, but there might be others. And now we have a nice visualization there in Grapho, right? So all you've done, Alex, is just save the file, import it here, and we could, I don't know if that's the tool that we want to use to exchange, to collaborate, to annotate. That would be a good way to do it.
Yep. Yeah, and so like you said, we can just download this directly from Claude Desktop here. And yeah, this looks accurate. This looks like it exported correctly. Looks just like our the visualization we had in Claude.
Excellent. That's
great.
That's pretty cool. There's a couple of questions. I mean, one is similar to what we mentioned before. Someone is asking, it looks like data in the model. I mean, the model is not capturing the duration of the occupation. I think in what it means, how long, what period that person lived at that particular house. I think, again, is one of those things that we didn't specify in our requirements, in our use case, in the questions. And that's probably why it's been ignored. Or maybe the information may or may not be available. But it's true that that could have been something that we want to extend the model with.
Yeah, it's so one of the things that we have going on here with the prompt is that we're really enforcing the focus on use cases. So by enforcing that, the agent is kind of forced to take a look at the use cases and square that with the data that it's provided. So ideally, we're not going to get too much extraneous information in our data model that isn't particularly tied to what we're trying to solve.
Yeah, and I think that's, you were mentioning before, I think it's good practice, right? So be iterative. I mean, solve start with the problems, with the kind of workloads that you want your graph to cover, and then extend it as needed. So probably I think we could take an approach like, let's over-engineer, let's try to model the world before, but I think this is kind of a more agile approach, which is the one driven by having a collection of questions. So yeah, I don't know if we're planning to touch on these today, probably not, but maybe worth mentioning that there's the kind of the inverse flow as well, right? So this server, if you happen to have, let's say, we worked in the other way around. So you've used Grapho or any other ontology development tool like Web4j, and you have an existing or a first version of an ontology in OWL. You could also import it using the tools in the server, and then take it from there, right? You would starting model, and that would be an alternative path as well. So you could,
Yeah, so we can load from Owl Turtle. We can also load the Arrows web application that Neo4j supports. So we can import and export in that format. We can also just provide a JSON representation and ask the agent to do the formatting or the conversion rather on its own, and see that will probably have varying degrees of success, but it's definitely something that's possible as well.
Cool. I think we have another question. It's more is about the construction of a graph. Of a graph to an OWL ontology. So I don't know. I'm not sure. Because Marc Henri, he seems to be asking whether we can do the translation from the graph, from a Neo4j graph to an OWL ontology. Well, if I don't answer it correctly, please rewrite. But yes, there's another possibility, which is if you have let's say you start from some data in Neo4j, so you have an existing graph, you can automatically generate, basically introspect the model. So there's functions that give you the list of nodes and relationship and properties, and this can also be exported as an OWL ontology. I mean, we're using this kind of idea of graph schema, graph model, and ontology as synonyms. It's true that there are some constructs in the ontology space that we're not using in this case, but this is possible, and that would be another path, right? If you have an existing model that you want to extend, or that you want to iterate on, or that you want to evolve, that would be another possibility. I don't know if I've answered the question, Mark. Please let me know, and if not, you can repost. So yeah, I think. Well, I don't know. Have we covered the whole exercise? Yeah,
I think so. Yeah, and so we also have additional resources here. These are just the links that were in the presentation, and then information on Claude Desktop and Grapho as well, and links to the data.
Good stuff. So and I guess the one possible call to action here would be for people to go try this and maybe submit pull requests to you, or maybe help improving it. What's a good idea?
Yeah, absolutely. Yeah, if anyone has recommendations for features for the data modeling server, it's an open source project, so you can follow the link here in the resources page, and yeah, open a PR or raise GitHub issues if you'd like to see something.
Good stuff. There's another question. I think that's a general one. If we're going to be sharing the slides, I suppose that will be the case, right? And yeah, you will have all the links behind these headers, and you should be able to get all these resources. Good.
Yep.
Any more questions? I don't know if I've left something unanswered, but I think we've covered pretty much it all. So I don't know, any additional questions, anything, people attending? We have one more minute, couple of minutes. If not, we can hand it back to Joao and end the session here. Good. There's lots of positive thank yous and great presentation, Alex. So good job. Well done.
Great to hear. Yeah. All right. Well, I guess I can't really see the chat, but if we don't have any questions, I guess we can just
that's good.
Call this presentation a little early.
Perfect. Yeah, it's just 1 or 2 minutes left, so we can I think jump backstage. So good job. Thank you, Alex.
Awesome. Yeah. Thanks. Yeah. Thanks, Jesús, and thanks everyone for attending.
Cheers.